In this video, I'm going to give you an overview of top 10 DevOps tools in 10 minutes. Tools that you should master and will definitely enhance your DevOps skill in 2024. If you are ready, let's get to it. Number 1 on the list, Linux. As part of DevOps teams, one tool that you must get right is a system for operating your application's development, testing, and production environment effectively. And the most common operating system for this is Linux. At the basic level, having a working knowledge of Linux commands, file system, networking, and security concepts will greatly enhance your effectiveness as a part of the DevOps teams. It allows you to bridge the gap between development and operations, facilitates automation, ensures smooth deployment and management of applications. So it is a kind of a must to have here. You want to learn more about Linux? Check the link. The question is, where is this environment that we are testing and deploying our applications to? These days, almost all the servers that host our applications are accessed and operated remotely. This is where cloud platforms like AWS come into play. Alternative to AWS, we have Google Cloud, Azure from Microsoft. AWS asks many services, including virtual instances, security groups around servers, from which we access the applications running on those servers. We can configure the servers and many other activities. If you want to learn more about AWS, check the link in the description. Imagine working with thousands of servers, with tens of thousands of applications, and all of a sudden, everything gone, just like that, because of misconfiguration or whatever reasons. How can we possibly recover all that? How can we get back to this same state again? This is where infrastructure as code comes to help, because it will be difficult and sometimes impossible to recover that manually. So with infrastructure as code, we can code the entire setup, spin up infrastructure resources, set up Kubernetes cluster, install all the services, and if something bad happens, we just run the scripts and recreate everything. In this category, Terraform is the most popular tool that allows infrastructure as code. If you want to learn more about Terraform, check the link. The reality is that most of the DevOps activities centers around working directly on the servers, like installing packages, doing security patches on several nodes. So with hundreds or thousands of servers, it is not realistic to be doing security patches or doing upgrade to the latest packages on those servers one by one. You will not want to be logging into each servers manually and executing the scripts, right? This is where configuration management like Ansible come to rescue. With Ansible, just write a script once, provide with a list of servers as targets, and it will automatically push and execute scripts on those targets and give you a desired output you want. You want to learn more about Ansible? Check the link in the description below. Okay, now that we have provisioned and configured our environment, we need to start releasing and deploying our application to these virtual machines, right? But in what form are we packaging and deploying these applications to the end environment? It is interesting to know that the modern way of packaging and running application is what we term as containerization these days, with Docker leading in this category. Docker packages everything the software needs to run, including libraries, code, and runtime. With this, we can quickly deploy and scale applications into any environment. So how do we achieve this? We will build a Docker image in the pipeline, then push and run the applications as a Docker container on the server. If you want to learn more about Docker, check the link in the description below. With the introduction and benefit of Docker comes also some challenges. Problems like how do we restart applications when they fail? How do we scale and replicate applications if they are getting a lot of requests? How do we run distributed applications like database clusters? Making sure that the application is always available and many other issues. So how do we manage all this? With the help of Kubernetes, which is a container orchestration platform, we can solve all these challenges. So Kubernetes has an auto healing feature and a network layer that manages thousands of containers. Scaling applications up and down as we need is done easily. You just specify replica counts in Kubernetes deployments. We can also scale servers up and down by adding additional node easily. If you want to learn more about Kubernetes, check the link in the description below. It's good to know how to set up our infrastructure, build and manage our applications. But the question is, how do we better instruct and make changes to both our infrastructure and applications through the interface? As a DevOps guy, writing code and scripts, especially in Python, YAML, and Bash scripting, is a must because at the end of the day, infrastructure as a code is a code. Configuration as code, pipeline as code, they are all code. And if you are writing Docker file or Kubernetes manifest file, that is also code. So a code editor such as Visual Studio Code that easily integrates with your development environment is highly useful, especially if you get some nice extension and plugin for specific languages and tools that actually help you write those scripts effectively, like syntax alighting, auto completion. So if you want to learn more about Visual Studio Code, check the links in the description below. It's very clear that you are not going to be working alone, but instead collaborating with others in a team, right? So far, we've seen the need to be writing mostly infrastructure code with code editor like Visual Studio Code. As a result, part of your work is to make that code available and transparent for the team, for other engineers to work on, who will also have access to the history of changes you have made to the pipeline. So you need the knowledge of Git to apply infrastructure changes the same way as application changes, right? For these reasons, it involves integration with Git, cloud platforms, Docker registry, pipeline as code. Particularly, we need a remote Git, and GitHub shines in this category. If you want to learn more about GitHub, check the links in the description below. And now our system is running smoothly and we have automated a whole lot of operations. But what if things go wrong in our system? Let's say someone is trying to hack into our system, or CPU and memory resources are being used up, or third-party applications like database are under heavy load. At this point, it is not a feasible option to be logging into thousands of applications to see what is going on. So we need an automatic monitoring and alerting system in place that use the data that we have in the logs and alert us if something is out of normal at all levels of the system, like infrastructure, the runtime, and application itself. For this, we have a popular monitoring tools called Prometheus. If you want to learn more about Prometheus, check the link in the description below. Finally, at the center of DevOps is automations, right? Where we automate all the pipeline processes, also known as continuous integration, continuous deployment. CI/CD tools is the most important of any DevOps toolbox. One of the CI/CD tools that is currently gaining popularity is GitLab CI, mostly because of easy integration with Git and the cost of setting up automation servers. But there are great alternatives like Jenkins, which has been the industry standard quite some times now. And we also have GitHub Actions, Circle CI, which are also really good. CI/CD tools are used to automate and run and test, of course, build applications. do different type of applications workload, and deploy to the end environment. If you want to learn more about GitLab CI, check the link in the description below. So when you are building DevOps processes, these tools are always combined together. They work together, right? So learning these tools in isolation is challenging and does not even prove you are practicing DevOps culture. So we advise you to keep learning how to combine them in a proper way with industry-based practices approach. I hope this video is helpful. Feel free to share this with others. If there are points that you notice that I have missed, kindly let me know in the comment section below. You can also learn with others motivated DevOps engineers in our community. Check out the links to join in the description below. Please don't forget to click the like button and subscribe to this channel for more engaging videos like this. And with that, thank you for watching and see you in the next video.